the Research and Development Cell of Kannur University, in association with the Internal Quality Assurance Cell, organized a public lecture program on various topics from the 12th to 23rd July 2022. And the 8th lecture was on the topic Computing the COVID-19 Death Toll in India. And the speaker was Professor Christophe D. Gilmotto, Center de Sciences Humaines, New Delhi.
Thank you for the introduction, and namaskaram to everyone. I'm very happy to be here, and I've already enjoyed a lot of Kannur hospitality, so I've been really well treated by my colleagues at Kannur University, and even so, it's my first visit to North Kerala. I think I'm not going to forget what I've already discovered and enjoyed during my brief stay. Today, I decided that I would discuss with you certain things that we demographers do when we actually don't have statistics. How do we go about figuring out numbers, giving estimates, when we don't have the proper data? And this is something that, as a demographer working on India, I've been facing since I was doing my PhD, how to compute figures when you don't have the necessary data, or you have imperfect statistics, and you have to re-estimate them and do what we call indirect estimation. And this is very challenging for a demographer, for a statistician, for applied statisticians, for social scientists, because we create knowledge from sources that are very often inadequate. And of course, it used to be like that in India in the past, where there were very few sources, but still now we have some incomplete picture of the country. For example, just 2 days ago in Mumbai, I was showing marriage rates. For any country in the world, especially industrialized country, marriage rates are published. Every year you know how many people have married, which age, and so. But in India you don't. Why? Because marriages are not systematically registered, and so we don't have statistics about marriages. So even to compute that, we have to use indirect method. Here what I'm going to talk is, of course, less joyful than marriages. I'm going to talk about COVID estimation. And first, let me show you, or let me give you an outline of my presentation. First, I will talk broadly about COVID and what we know about the measurement of COVID and some attributes of COVID. Then I will talk about different ways to measure COVID mortality in India. And then I will show you how I came up with an alternative set of estimates regarding COVID mortality in India. And I will try to describe the way I went about estimating using very unconventional sources, but I used also data from Kerala, and you will understand why. And then finally, I will show you the results, compare them with other results, and draw some conclusions about the situation, what we know about COVID mortality in India compared to the rest of the world. So let's start with the big picture. 1 year ago, we had data collated by different organizations including American universities. And we had some idea about the distribution of the deaths due to COVID, up to, here it's up to June 2021. And here you can see the map. You see that the size of the absolute number of COVID deaths was in a way relatively small in India, almost nil in China, according to official statistics, but rather big in Europe, you can see, in many countries, and also in North and South America. But of course, it's all related to the population size. So when you compute the rates, that is COVID deaths by inhabitants, you get a slightly different picture. But, no, okay, there's no pointer. Yes, yeah, but it doesn't show here. Sorry. You can see that, for example, the highest rates are in Europe. They are very dark red. And also in the US and in Latin America. Rather low rates, almost the lowest rates in Africa, and medium rates in West and South Asia, and very low rates in East Asia. Now, one thing I did very early on, and at that time I was based in Paris, and I was under lockdown. I came back from India one day, and 2 days later I had to pack my thing from my office and go back home, and I thought, like you at the same time, that it would be only for a week. But in fact, the lockdown in Paris was for almost 3 months. So during lockdown, I started compiling data, and what I did is, because I'm a demographer, I looked for countries that were publishing data immediately, what was the age distribution of COVID death, not infection, only death. I look at death. And then again, I computed death rates by age and by sex. And then I realized, I think it was the first time that we realized that the distribution was extremely regular. So starting from low age, 0 to 10, then it would, death rate would increase in a linear fashion up to high age groups above 80. And if you look more carefully, you look at the scale, it's not the ordinary scale, 1, 2, 3, 4. It's a log scale. So it goes from 100 per million to 1,000 to 10,000. So a rate which is here is 10 times smaller than the rate there. And it proved to be very useful, as you will see, to discover that across mortality, which is of course a dramatic event on which we think it's very difficult to reflect statistically, we can discover this very strong patterning of mortality. And that's something I could do, I think it was in mid-2020, or maybe in September, when I was able to do that. So very early on, we had this knowledge. Oh, yeah, sorry. Male, as usual, I put male in blue and female in red. And male rates are significantly higher by a factor of about 50%. And then I did the same with a lot of individual countries later on. And I'm not going to show you the detail, but this is for male mortality. And for all these countries, again, you see that it's almost like a straight line. Now, it may be a straight line, but it may be higher. So everybody has higher death rates. a country which is very affected, like Brazil, or it may be very low, like for example in Japan or South Korea, for which we had good data. But still, it's always straight. And that's, as you're going to see, it's not completely indifferent. So again, for female, it's the same. So finally, after a year, I was able to come back to India. And that was in March of last year. And I arrived in Delhi, and I was supposed to stay for 1 year and to do different work. And by the time I arrived in Delhi, maybe you remember that time, February, March, everybody thought that COVID had been, how would I say, suppressed in India. Due to various reasons, COVID rates were very low at that time, and it looked like the COVID crisis was over. But of course, it turned out to be quite different, especially seen from Delhi. Because this is what I immediately encountered. After a month, people starting reporting deaths everywhere in India, but especially in Delhi. And I was with my wife, and we got really scared, you know. And especially when a neighbor of ours who was supposed to come for dinner died after 3 days instead of coming. And a lady in her 50s, you know. And so we realized that COVID was not just a statistic, it was something that was happening to us, to our friends. And we had 3 friends who died within 3 months. And then I started asking questions around me, of course, mostly over the phone or over Skype, to my friends. And they all say that they have had, that they knew friends or cousins or relatives who had been affected, and many of them died. So that's at about that time that I realized that numbers that we were getting in India didn't really match with our environment, with the number of people who were affected or who even died. And again, but that time in India, I was under lockdown, so I was staying at home and working with whatever numbers I could find. And so they were numbers that were published, but what we want is usually to have the proper cause of death and also the age, sex, locality, date, or sometimes comorbidity. That was what was prescribed by WHO. But what we got in India at that time was just a number. No information, even about the sex of the disease, not to mention about the age. And you had just, you know, numbers like what I'm reproducing here. And that was the only thing we could go by. And on the top of that, there were severe potential issues in India regarding the quality of the registration of COVID deaths. So let me mention some of them. First, that people were unable to identify the correct symptom of COVID deaths. For example, a lot of people died because, as you remember, death rates are very high among the elderly, so old people died, and it was attributed to old age. But as you know, nobody dies of old age. There's nothing, it's not a disease. Old age is just, you know, a status or a demographic indicator. You die of something, and when it was COVID, it was in fact attributed simply to old age. And then there was testing capacities, which were, of course, under great stress. with a lot of people who were not even able to be properly tested. And then there was also the reluctance to report COVID. You know, in my own neighborhood in Delhi, it was a matter of shame when the municipality would stick, you know, an information saying that in this house there are some COVID cases. I mean, it happened, not because of us, but because of our landlady. And for 2 weeks, you know, nobody would come inside. Anyway, we were still under lockdown. And then there were also reluctance by local authorities, because also maybe you remember what it was 2 years ago when, for instance, governments, regional governments would be blamed or would blame other people for bringing in COVID in their region. And so there was a political game that was related to COVID, even targeting specific religious groups or specific regions for being responsible for COVID. So again, it was in nobody's interest from a political point of view to properly share all information regarding COVID. And plus, there is in India, on the whole, a tendency to under-register deaths. That is been there for long. Now it's being reduced, but still, we estimate that there are in between 10 to say 30% of births, depending where you are, you know, which may remain unregistered in India by the official registration system. But then something happened early on, you know. Here we are in May 2021, and I think Divya Bhaskar was the first newspaper to publish data. You know, front page, and I'm going to show you with more explanation some of this data, you know. They showed, like, for example, so it's a Gujarati newspaper. For example, for Rajkot municipality, they compare the number of deaths in 2021 with that of 2020. And they say, look, there are 10,000 more deaths. That's here, you know, in the newspaper. And they say, but compared to the number of official COVID deaths, only 300, whereas they see an excess of thousands of deaths. Surprisingly, you know, that's why I'm saying, where are the demographers? The journalists were the first to pinpoint the gaps in the official statistics. And then, at the same time, it was done more systematically in countries with better statistical data, and they started recording what is called excess mortality. So let me show you how it goes. Here I'm using data from 2020 from the US, and it's for one specific age group, males age 55 to 84. This is a very especially vulnerable age group. Huh? Not only are they very old, but you have also, it's a male population. So what you do, you compare what has been observed in the past every week, you know, that's the trend, with fluctuation during the year, because, for instance, there are more deaths in winter. And you compare it by week with what is happening in 2020. And then you see the gap suddenly, you know, around the 15th week. That's about March, you know, late March, April. Suddenly a peak. And excess mortality will be simply the difference between registered expected mortality and observed mortality. That's also what we did in historical demography to estimate the impact of epidemics in the past. We would compare how many deaths were registered 1 year, and we compare it with the preceding year or the year later. So excess mortality became a different way to assess the strength of the mortality crisis during COVID. And as I show here, it's a very simple formula. COVID deaths will be the difference between observed and expected deaths based on earlier trends. Now, there are some issues with doing that, and maybe I'll get back to it later on, but there are things, for example, there are some non-COVID deaths that may be attributed to COVID. For example, you remember the condition, the situation of migrants, and also you know that there was a relative collapse of the medical structure with people unable to see a doctor, even for non-COVID reasons. So maybe there were deaths that were not technically due to COVID, but just due to the collapse of the health system. But there were also deaths delayed. The best example is road accidents. There was far less traffic, so far less road accidents. So the excess deaths, different in number of deaths, may be mostly due to COVID, but there are other factors which are still now poorly known. And in India, there are additional technical issues, especially because even what we call expected deaths is not obvious in India, since there are issues in death registration, for instance, as I told you earlier. Anyway, a lot of people, and I will show you results, use the excess mortality approach. But at that time, again, we are last year in May, June, it was impossible to use excess deaths the way this Gujarati newspaper had done, because you would need death reports from everywhere in India, not just municipalities in Gujarat. You know, you needed a better, a more comprehensive overview of mortality in India. So I decided to go for what I call the sample approach, in which you use a small population as a sample for all India. But that small population has to have pretty good data. So this is again something that we do in historical demography. For example, in France, we have a sample of people whose name starts with TRA. So the TRA sample. And they are used in the 19th century. People have taken all statistics available, but only with people with that name. And so they are able to follow them. So it's a very small sample, but it's supposedly a representative sample for all regions or social groups. I'm giving you other ways to go about that. For example, there are pioneering studies in Chinese historical demography, where they have used spatial records for particular population or genealogies. In India, it has been done to a limited extent from parish records. You know, so Christian areas where people have been able to collect parish records from the 19th centuries, and sometimes in Goa even for earlier periods. So it's a typical way to approach a situation where you don't have systematic and exhaustive data on death. So what you want to have, I mean, just to give you the theory, is first you need to have a sample pertaining to a very specific population that you are going to use as a denominator, how many people were exposed to mortality risk, and you need to know whether they belong to that population or not. It cannot be, you know, a fuzzy definition for a group. Second, you need to have good COVID estimates about that population, and that's, of course, not easy. Samples have to be large enough. We need to have age and sex to make sure that this is not a sample only of old people or young people, because then if we don't know exactly the age distribution, that would be severely biased. And also it has to go up to what I call the pre-vaccination period. So for me it was up to May 2021, but I mean the vaccination drive started slightly earlier. And later on there were too many people being vaccinated, so there might be a bias. And also the sample has to be representative at an all India level. So I looked at many samples, and here are some that I discarded. For example, one of the biggest one was Indian Armed Forces. Why was I interested? Is that because COVID deaths were very well recorded. The medical system for armed forces is one of the best in India. So they did record COVID deaths. Now, I could not keep it because I didn't know enough about the age structure, and especially you see you have several lakhs of army personnel, but very few deaths. Why? Because most of them are young, you know. Sometimes they are in their 20s, you know, or sometimes they leave the army before they reach the age of 40, so less susceptible to risk. Another sample, for example, was medical community, but I mean, as we know, they were extremely exposed to the risk of mortality, unlike ordinary citizens. So again, lots of samples I had identified and I had to discard them, and finally, I zeroed in on only very few samples. One is made of MLAs and MPs from all over India. The second one is based on Kerala statistics. The third one is about the Indian Railway personnel. In fact, it's extremely useful, this one. And the third one was just used for control. It was from the Karnataka School Teacher Association, where also they recorded COVID deaths. Now, let me show you about the MLA sample, because that was the beginning. I was like everybody reading newspaper. They were talking about deaths here and there, but again, very anonymous. And then I realized that MLAs and MPs were dying of COVID, and it was immediately reported. Even when they went to hospital, it was reported. And when they end up, for some of them, dying, that was also reported in several newspapers. So it was possible to look at, to identify, to list the number of MLAs or MPs who died during this period from press records. And at the same time, we had a list of all these MLAs and MPs. There are some people in Ashoka University who had compiled a list of this MLA and MP population by age and by sex, which is exactly what I wanted to do. So here I'm describing the sample. I don't remember, but there were 5,800 individuals with a majority of men, but with a significant share of women, more tending to be older than the average population. And I compared in red, the cumulative number of deaths among them, and I compare it with the Indian official statistics, and I saw that it was comparable, even if the number was relatively small. There were, how many deaths? I don't remember, but maybe 43 deaths among them. Even if the number of deaths was small, it matched the distribution in time of and for instance, here is one MLA who died in early 2021. So he's MLA from Palghat area. And it was reported, but it was not only reported in Malayalam, it was reported everywhere, also in the English press. So I had no difficulty to identify him and to put him on my list. Now, as a statistician, I'm always afraid of bias. And so a lot of people were telling me that these people, that the MLA sample was either more or less vulnerable to COVID mortality. They were less vulnerable because they belong to the elite of society and they have easy access to hospital when a lot of people were just refused, denied access to hospital. So they had this, and of course they have more money, they have a different lifestyle, they are in better health condition. But then they were also exposed to more risk because a lot of MLAs refused to stay at home, and even during the lockdown, we are trying to meet. I'm talking about the lockdown in during the first year in 2020, and in 2021, if you remember, there were also elections. You know, local elections. In, for instance, in Uttar Pradesh, there were panchayat election or different elections, and MLAs had to be on the field, you know, on the ground, meeting people in their constituencies. And as I'm saying here, political events hardly stopped in 2021 with many electoral rounds. You may remember the one in West Bengal, which started, the election were just during the peak of the epidemic in 2021. So less exposed, more exposed, but maybe more privileged subpopulation due to their elite status. Now the Indian Railway sample was more interesting because it was way bigger. You know, you have 13 lakh employees, and they do have also a very good medical system, and they immediately register COVID deaths because they knew that they could apply, the family knew that they could apply to get some benefits. So early on, we had statistics about them. What was more difficult for me was to get their age distribution. So we had indirect information, and finally I was able to reconstruct the age structure. Again, I need to know whether these people are young or old because they would be differently exposed to the risk of mortality. I'm not talking about infection here. Again, I'm talking about mortality. And the question was, if I have the death rate for one big sample like Indian Railways, but these people are aged 20 to 60, because after age 60, most of them are retired, how do I extend my result to the entire population, that is even to younger people and older people? And that decided to look at Kerala, because Kerala, right from the beginning, didn't try to hide the severity of the crisis, but in fact shared a lot of information and had sometimes very aggressive campaigns to warn people against COVID. And its action, the action of the local government, the regional government, was seen in India, rightly or wrongly, as one of the most effective efforts to contain the epidemics. But one thing very important in Kerala is the quality of statistics. For example, each state in India has a so-called COVID dashboard. Now, if you go to the COVID dashboard of, say, Rajasthan or Bihar, apart from the fact that it is only Hindi, you have very few information. Again, you just have numbers. Maybe at best you have the number of people who died of COVID in a single day, like 27. And sometimes you know where they are from, in which district they died, but sometimes you don't. In Kerala, it was much more sophisticated. So, for example, here it's what I got on the death certificates, the death registered, COVID death registered for 1 week in Kannur district. And you even have, which is, from my point of view, is a little bit too much, you even have the name of the people. So, luckily, you cannot read that. But you have the age and the name and, of course, the gender of the people. So everything is given there. You can still go in 2 minutes and get the list. And again, we know that age is better estimated in Kerala than elsewhere in India due to high level of literacy. So it's not like every old woman will be age 60 or 70. No, they can perfectly be 74 or 69. And that's what you get in the list. And you have also the distribution that I've shown there by district. But I didn't care so much about the regional distribution. I cared about the age and sex distribution of deaths, which I compared, I computed death rates, and Kerala is in black. And I compared it with that of the US, Brazil, and Sri Lanka. And surprisingly, Sri Lanka is in green, and see how close it is to that, to the data from Kerala. So it's not, I'm not just saying that Kerala is very similar to Sri Lanka. I'm saying that death patterns look exactly similar, and since they are similar, and they are also similar to that, say, observed in Brazil, but at a lower level, for all ages it's lower, COVID death rates are lower, then you see the consistency of data. You say, well, maybe there is some type of underestimation, but there seems to be no bias in the underestimation. The pattern is just like that of Sri Lanka, which has slightly better statistics, death registration statistics, or other countries in North or Latin America. So that's one way to say, okay, so maybe I can use the patterns from Kerala and apply it to the rest of India. So for those who love numbers, you can even do some modeling of death rates using that kind of death rate. You take the log, and then you have some kind of simple equation. And I did something even more complicated in order to fit the data for Kerala. And it turns out that each of these parameters, A, B, C, and D, have some meaning. Either it's the level of mortality, either it's the shape of mortality, or it is for young age mortality or old age mortality, what you see at the end or at the beginning of the curve. Anyway, I used that modeling, and then I applied it to the deaths of Indian Railways personnel, and I said, so I know for a specific age group that this is the actual death rate. Let me see for other age group using the patterns borrowed from Kerala. When I say patterns, I don't mean the level of Kerala. I just mean the shape, the overall shape of the mortality, the death rate in Kerala by age. And I did that differently by. So finally, I was able to estimate the death rate for the population which was not covered among my MLA sample or among my Indian Railway sample. And doing that, I finally got new data. So, for example, here the numbers are in millions. And from these are the official death rates for different periods. And then I did the computation up to November, the 1st of November 2021. And the official data were between 4 and 5 lakhs. It's in million. My number was around 32 lakhs according to Indian Railways, and according to MLA sample, 36 lakh. So finally, I see that compared to the official numbers, my number were between 7 and larger by a factor of 7 to 9, which is huge, but which is something that we felt was possible in view, especially my personal experience, in view of the number of people around me who were affected and in fact who died during the, at least 2021. So now that's what I call the payback time, because we got also some confirmation later on when claims for COVID deaths started to appear, especially they hit insurance companies, and they were not at all on par with official statistics. For example, for Gujarat or Telangana, this is a paper published in the Times of India last year. So there was a severe mismatch between official data and the number of claimed deaths due to COVID. Finally, after my work, before and after my work, there were some other people who used different methods. Most of them use what I've described as excess mortality. Compare what we have in terms of mortality between 2020-21 and what we had earlier, for specific states. That's, for example, the case for the WHO. And some people used also sample. There was a paper of Science, in Science, published maybe in January or February. And look at the results. We go from 3 million to almost 4.7 million. And when you compute the average of all the estimates, except mine, you get 4 million. And mine are around 3.5 million. So possible, we are in the in this area of, in this level of mortality between 3 and 4 million, and maybe my numbers are lower because both samples were in fact slightly privileged. For example, I've not discussed that, but in Indian Railway sample, a lot of people stopped working during the first lockdown, so they were less exposed. And some people are not in contact with the public, because they manage, they manage railway tracks or many things, so they are not in touch with the public, so underexposed to mortality risk. Whatever the case, we know that we are around 3 to maybe 5 million of deaths. And one thing also that I wanted to tell you before closing is, where does finally India stand in comparison with other countries? So, you start with the number of COVID deaths. Here I'm just using my numbers, but you remember it between 3 to 4 million, that is 30 to 40 lakhs. And so if you look at the COVID death rate, it's just the number of deaths divided by the number of inhabitants. India may be much higher than the rest of the world, but is lower than Brazil and on par with that of the US. So nothing special. But what you have to do is to standardize by the age of the population. Because again, India, maybe I haven't stressed that earlier, India is younger population than the US. So when you compare by age groups and you do what we call age standardization, you end up finding that US has a much lower death rate. A lot of these deaths were in fact due to the fact that the US has a much larger proportion, like say 20% of the population above 60, when it's around 10 in India. So double number of highly vulnerable population. And now we see that India has a higher standardized rate than Brazil. It may not be the highest in the world. As per my knowledge, there are 2 other Latin American countries, especially Peru, that have higher standardized rates. But standardized rates tells you how much was the population affected by COVID mortality once you control for its specific age. Now, I've quoted also the fact that there have been estimates by the WHO that have been published maybe 2 months ago, and I've not used them to recompute everything. But as you've seen, India was given a much higher number of deaths than even I computed, above 4 million. So that would mean that the standardized death rate in India due to COVID was probably higher than I've computed. Now, as a conclusion, I would like to stress, first of all, that even when you don't have the data, the necessary data that, for instance, we would find in Western Europe, where data are published every week about the number of COVID deaths, certified, coming with a medical certificate, and then you have the age and the sex of the deceased. Even when you don't have that, you can find ways. So it's statistics is at times also, or at least social statistics, a very applied and resourceful science in which you will pick up whatever. Remember, I use data also from Kerala. I've not mentioned about the data from Karnataka, which I used just to check the results, and it matched. But you may find indirect sources. Now, this is not the end of the story. There are so many things that we still don't know. We don't know, you realize probably that we computed the deaths, total number of deaths at all India level. But we don't know about regional differentials. For example, how much was Delhi actually affected, or Mumbai, to name 2 places that were especially hit in 2021, but also in 2020. We don't know also the difference across socioeconomic groups, keeping in mind that the middle class were far less exposed than the working class or than certain groups that were always in contact with the rest of the population. So we have still no idea. And also, we have no clear picture of the impact of national and regional policies. But you do remember that in 2020, there was a severe lockdown policy decided, if I remember well, announced maybe 3 hours in advance, or very, very short, Well, it was very painful for many subpopulation, especially migrants, but I believe it was incredibly effective. And in 2021, we had a second type of lockdown, which I went through in Delhi, but it was a much weaker lockdown. Sure, we couldn't cross the city limits easily or travel across the country, but there were a lot of things that we were able to do, and there were still, street vendors and a lot of people moving from one house to another one, family moving from one place to another one. And that was precisely the time when the COVID mortality was the worst. So we still have no good perspective, most probably because discussing these things are very political and controversial in India, so people treat carefully. But we need to understand what happened because it may happen again, so we need to know what kind of policies are more effective and see also what are the exact economic, for instance, or social costs of these policies and how to balance them with their obvious health benefits. Thank you very much, and I welcome all questions.
Thank you, Professor Gilmotto, for that insightful session. Now the audience may ask your questions.
Many of the medical reports says that people who have been affected by COVID is suffering from post-COVID complications. So, do you think this is being considered while we compute the after effects of COVID? How long do you think we have to wait for the actual number of deaths happen due to this post-COVID complications?
Thank you for your question. In fact, we had such a discussion with one of your faculty this morning, and we were discussing the situation of people who were affected by COVID and died maybe 6 months or 1 year later on. So it is near impossible to attribute the death taking place after a year to COVID, because people may end up dying from, I don't know, something that looks like a respiratory disease or a heart disease, even if that was triggered by COVID. So there is no direct way to address this situation. The only way is through excess mortality, which I haven't done, but to look whether 6 months later or 1 year later, and that would be, for example, in 2022, whether we still see an excess number of deaths. Then we would vaguely know that it may be a post-COVID impact. That's a possibility, but otherwise, from a medical point of view, the research on the long COVID effects are not very clear, you know. This is really one of the weakest parts of the science, of the COVID science today. So I must confess that we, till today, have limited information, and that the only thing we can deal with the only way to deal with it is to look at whether 1 year later we still see some kind of excess number of deaths.
No questions?
Sir, your study has concluded that the death toll in India is in between 6 to 8 times higher than official records. And have you identified any of the problem for this is not there in official records?
Well, I've tried to list the several issues that may have affected official records, down from the micro level of families unaware of the nature of the disease that has caused the death, or the name, or even their willingness to report it, up to a higher level where it was not always possible to test people, and without being tested, a lot of deaths could not be attributed to COVID. You might have read in the press several reports of people who were, journalists from the urban middle class, talking about death in their family that were not reported as COVID deaths. So that it was a very complex situation in which there were distortion and under enumeration of COVID deaths at all layers, from the affected families up to government statistical offices.
Thank you, sir.
Any more questions?
Thank you, Krista, for this lecture. I'm sorry I missed the first part of it, but I don't think I missed the main part of your lecture. I had 2 or 3 questions. One is the first thing that you mentioned about journalists covering it very well, which is true. So, why do you think, you could speculate, why do you think that epidemiologists in India, I can understand people working for the government, but people working outside the government, strictly outside the government, did not really undertake such an exercise when it was clear to everybody living through the epidemic that it's hugely underreported. So that's the first thing, because in fact I asked the earlier speaker in the morning, who was a statistician, practicing statistician who had done work. He mentioned his work during the H1N1 epidemic in Pune in 2009, how the data was kept back. But this time, nobody intervened at scholarly level here. The second question is, you have looked at excess mortality. You have based the entire thing on excess mortality, whereas some other people have used registration data, whether it's CRS data, to estimate. Could you say why you went for excess mortality and did not use registration data after necessary corrections? And second, in this entire modeling exercise, I don't know statistics, I don't know whether that tempo that you mentioned in the equation refers to the transmissibility of so it's not the transmissibility of the disease. When the virus is mutating during this time, how is that captured in your model? Because some of the models are using some Monte Carlo simulations and so on to capture the changes in the virulence of the virus. These are my 3 questions.
Thank you. I must say it's a bit difficult for me to exactly understand why there was little scientific mobilization in India itself regarding COVID mortality, and why most of the papers that I've shown the result of were published by teams where you had expatriate Indian scientists. For example, one guy in the UK, or colleagues of mine in the US. And I was myself surprised. I tried to approach colleagues to work with them, to get their feedback. And at that time, they were not willing or not interested in getting involved. in this. And I still cannot figure out, and I think maybe in the next couple of years, with more data, people will be forced to look again, because there will be new data coming, maybe a new census, or maybe new civil registration series for 2021, for instance. So I think there will be a late mobilization. But so far, yes, it was very surprising, and I do not have an answer, except that some people were reluctant or were afraid to touch the subject of COVID mortality from a critical statistical viewpoint. Otherwise, yeah, many sources that I've quoted are using civil registration data, but the civil registration data they were able to get from specific states, because they have not been officially published, but some states released some, and not only Gujarat, but some municipalities, and but again, you have states like Uttar Pradesh and Bihar, for which there was very little by way of official death registration data. So we still have somewhat of a regional black hole in central India, because that includes also Madhya Pradesh, Jharkhand, Chhattisgarh, a lot of states where we don't have even the basic data on the number of deaths by month or by district, for instance. Then when I speak about the tempo, it's, I'm afraid, very typical jargon. Tempo means more here the age distribution. For instance, there was a discussion about Europe, about why were death rates so high among the elderly. And that was about Western Europe. And then one answer was that a lot of the elderly stayed in old age homes. So there was a concentration of people. And so when one person was infected due to visits of relatives, it spread within the home. And we've seen that in France. You know, sometimes one institution would lose 20 patients within 1 month, and it was due to the. So we thought that how come the distribution is not always the same shape, and why is it maybe higher among the elderly or lower than expected? For example, it was lower than expected in Brazil. And people told me it's because the age population is much more dispersed within households. And I think that would apply also to India, where you don't have such concentration of age population. So even the tempo thing is something that is not easy to understand, and for which we have till now indirect information. And tempo here is just the age schedule, not the age level, but the schedule, whether it's more compared to, before 40 compared to above 40. Even so, we know it is increasing by age. And to give you a sense of the increase, for example, somebody who would be 20 years older than me had a risk which was 10 times my risk. So that may be very bad for somebody with 20 years, but that means also that somebody younger than me by 20 years or by 40 years mean a risk which is a hundredth of my own risk. So that's something that I guess was not really properly factored in right from the beginning, in order to protect the most vulnerable population, that is the elderly and even older adults.
Do you think virulence of the disease, of the virus? virus itself would have an impact, how it changed over time.
Yes, that's still something we don't know. We don't know. I don't think that there was. We've seen that what was easy to describe was the speed with which the virus could disseminate. So infection rates, tend to be much faster with the so-called Delta variant, and than the previous variants. But that's all we know about the lethality, the risk in terms of death rates. We don't see an age factor differential across variants. As far as I know, that has not been shown. I mean, some virus may have been more dangerous, but that would affect all age group in a similar manner, with, again, old age groups much more prone to mortality than younger age groups.
Yeah, I have one doubt. Because of underreporting, you are saying that the excess mortality rate is higher in India. But why not you do some, because this disease has a similar pattern everywhere.
Mm-hmm.
But why not you use the say meta-analysis if somebody has reported it really well? Then why not use that information to compute this mortality rate rather than just computing your average or that sort of thing? By putting weightage to the percentage of people who got vaccination or the population size or something like that.
Well, what was it? Of course, vaccination had a very important impact in India, but mostly during the second part of 2021, the second half. And that's also the time by which the epidemic itself, this wave, the second wave, petered out. So there was both the vaccination impact and also the fact that all epidemics stops at one time. They follow some kind of almost a mathematical curve, and they never go on killing the entire population. No, they stop at some time. And that's what happened around July, in July 21 in India. So, of course, there was a minor impact of vaccination, but at that time, just a small fraction of the population was vaccinated. And in North India, it was getting almost impossible to get vaccinated. I was vaccinated earlier in, I think, May or April and May, but it turned out to be very difficult 2 months later because there was a rush, and as you remember, there were not enough vaccination centers or even vaccines too. Now, some people have tried this approach by using external information about infection, but even infection was very poorly estimated. For example, at some point, in 2021, anybody could get tested anywhere in the UK. It was free of cost, and you could do that even every week if you wanted to, just like it is possible today. But that was not the case in India. It was either costly or difficult, and people were queuing up to get tested, so they would get tested only when the risk of being infected was very high, like 50%. So the so-called positivity rate. But that showed that a lot of people who should have been tested just for security reason didn't do it. So infection rates are very difficult to use as a source of estimation of mortality, precisely because they may be severe underestimation of the infected population. And so then there are other factors, but the link is not so clear, like, for example, population density. Of course, population density does increase the probability for viruses to disseminate and for population to be infected, but they are not strong enough. So some have done that. There is one study done by the British magazine, The Economist, that pulled together a lot of data into a black box that they call conveniently, machine learning estimation. So, and they've come up with numbers which are pretty similar, more closer to 4 million, if I remember well. But this is a method that is very difficult to replicate because of the type of computations that are involved. And sometimes it works well, and for some other countries it works very, very poorly. So, I've kept this national approach, using only for India, because I'm not sure I would have been able to use data from other countries, except to look at the shape. Like remember Sri Lankan data, you look at the age distribution of death rates, and they are very close, so that's a confirmation. But I would never be able to apply rates derived from another country, like say from Sri Lanka, to apply them to India. That's conditions are much more different, and we don't have a global equation where you can put, different social or health attributes, and then finally through a model get the number of deaths. That we don't have. We know that there are some factors that are correlated, but somewhat correlated, but it's not enough for an accurate estimation. Thank you.
Thank you, Professor Christo. I have got a question with regard to the question of compensation. So do you think that it's the question of compensation that has dragged down the official estimates? And a second part of the question is that whether in the long run the compensation will drive the official estimates up? Thank you.
No, I don't think there was any anticipation, except in terms of what I would call a political compensation or political retribution. But even that, we've not exactly seen that happening elsewhere in the world, that governments that perform well or poorly during the COVID pandemic were affected. So, but I don't think that there was any such anticipation of the issue of compensation. In theory, it is possible that people would also ask for compensation based on fake medical certificate, but I think there was really a time gap between the deaths, the pandemic time, and the period when people starting claiming benefits, and very few people are insured in India. So it's not exactly a representative population. And in sectors like, for example, I've mentioned the Indian railways, because there the relatives of the deceased are going to get compensation. They have their own health structure, which is of pretty good quality, just like for the military. So I don't think it's going to be easy for claimants to fake certificates. So I think that in theory, this may apply. This may be the case, that there would be fake claims, but you have to look again at which section of the population is affected, and whether they are really likely to be in a position to produce fake certificates 6 months or 1 year after the death.
Thank you, Professor, for such an insightful, another insightful talk. There's just one minor query. I just had this thing. the concept of underreporting, shouldn't we use it with some sense of careful, a sense of precaution, in the sense that there's this the general usage of the term underreporting for countries which do not. I mean, there could be two kinds of underreporting. One could be a genuine, a conscious attempt by a state to underreport the cases, and the other could be that simply because the state doesn't have infrastructure to record health infrastructure and all those kinds of things to report make accurate data, collect accurate data for deaths and mortality. So what I have in mind, countries like Africa, in Africa who have been blamed again and again for being for underreporting, or for that matter Afghanistan, a country like Afghanistan. Where will you place those countries when you're talking about the concept of underreporting? So I had just that in mind, that whether we should be careful in using the word underreporting when it comes to such a important issue like COVID deaths.
Yeah, thank you for warning us. And here I must agree that underreporting is just a word that you use when you want to account for the gap between what has been officially observed and what can be deduced statistically. Now, the process of underreporting is poorly known. But again, you know, with demographers, we have something special, is that they look at data and sometimes they have no prior idea of what they are going to find. And then when it happens, when they show something, then people are surprised because nobody has spoken about it, nobody has described it, or nobody especially has been able to put numbers into it. So there is a saying in French, which is something like, it's only at low tide that you finally see that some swimmers are naked. So low tide is a crisis, and finally you see at low tide stuff that you had never seen before. And now it's not an explanation about why it is so and how come registration was incomplete. You know, we still have poor explanation about that, but the fact is that there is a gap between what was registered and what seems to have been the case. And then it will take years, I believe, to improve registration system to be more ready, or to have different ways. To give you an example, the WHO very soon said that to report a COVID death, an official COVID certificate was not necessary. Of course, keeping in mind countries like Africa, where so few people were tested. So they had more a list of symptoms that would be sufficient to classify the death. But in India, there was a much more stricter interpretation of the WHO regulation. And people who had who were not, for which no certificate, COVID certificate was available, could not be classified as, I mean, in case they died, as COVID deaths. So there was some different level of flexibility. And then there are other countries where there were, where we have found high level of apparent under registration, and some of them needn't be as poor as African countries. For example, that was the case in Russia. And there was a debate among demographers and government statisticians, and finally, even the Russian authorities, I think in late last year, acknowledged that the number of deaths was much higher than their official account, by a factor, I don't remember, of 3 or 4. And because they keep deaths by cause in their statistical system, and it's absolutely necessary to project the population, they had to acknowledge that. And it's almost what the WHO did, you know, in order to be able to publish, for the United Nations to publish population statistics, which they released 2 weeks ago, what's called the World Population Prospects 2022. They had to wait 1 year, it should have been in 21, they had to wait 1 year till 22. They had to wait till the WHO computed the COVID deaths, I mean, indirectly. And once it was done by WHO, the United Nations Population Division incorporated these numbers into their population statistics in order to model population growth and death rate and like that. So when you do something like that, even if numbers do not agree with official numbers, you have to correct them in order to have demographic or statistical consistencies. But in India, because of the publication recently of United Nations numbers, and you might have noticed that something very important came up, the fact that India next year will have the same population as China, and that by the end of next year it will be the most populous countries in the world. When I look at the official numbers from India, in fact, it turned out that there are no official population numbers for 2022 in India. These are just projections, and there is nothing like an official number. Whereas in France or in China, or at any time, the government will give you some estimates saying this is the official number. And that number has to be consistent with the number of deaths the previous year, number of births and everything, so that you have the basic population equation in place. That's not the case in India, precisely because we don't have, how would I say, reliable number of births and deaths by year. So again, there was no need felt to properly estimate the number of deaths in order to be able to correct the official population number for 2022 or 2023. But one day will soon come where there will be an official number, and Indians won't have to wait for United Nations to produce an estimate. They will do it on their own based on the basic population equation, which is the population of 1 year equal the population of the previous year, plus births, minus deaths, and minus out migrants. Thank you.
Sir, I knew that R0 packages from R programming is useful for computing the basic reproductive number of COVID cases, and these packages gives us the accurate value, or any other packages available for computing the basic reproductive number of COVID-19.
Can you repeat the question? I didn't get it properly.
R0 packages from R programming is useful for computing the basic reproductive number in COVID-19.
Which program?
R0 package.
R0?
By use of maximum likelihood estimation. Reproductive number. That is
R0.
secondary cases.
R0. No, R0 is more about infection rates. You know, R0 doesn't say anything about death rates. It says R0 can be applied to any disease like flu or any non-lethal disease. You have for any epidemic disease can be modeled with different levels of R0. But that doesn't say whether the disease is going to be lethal with causing death or not. That's another issue.
So when you are computing the mortality rate, consider log linear and log quadratic models. Then this R0 can be considered as a Covey equation. When the spread rate increases,
But sir,
naturally there will be increase in the mortality.
Yes, well, there are many factors like infections that are, of course, behind mortality. But again, if you look carefully at what I've done and what most people have done, in fact, they are not looking at infection rates, because we don't see that they are robust enough. And then you need two information. First, infection rates, which may not be reliable, and then what we call the case fatality rates, which is how many people among those who are infected are likely to ultimately die. And that also, that number, the case fatality rates, there is absolutely no agreement. And you cannot apply one case fatality rate from one country to another one. That's also something we learned. So you have two parameters, infection rate and case fatality rate, that are shaky. So that's why you would better do without any consideration on infection rates. And that's what you find for mortality estimates. There's hardly anything about infection, even if we know that infections were behind, of course, the transmission of the disease and final mortality.
Thank you, sir, for your lecture. When about Kerala, you said we actually over-reported the demographic details. We even reported the names. So why do you think it was a bit too much, and what do you suggest instead?
Well, here it's, I think there are lots of data which should be anonymized, and that I don't think the name of the death, of the disease is useful. It should be, the information may be used as a statistical information with the place of death or comorbidity or age or stuff like that. But the name, I don't see any reason why it should be there and why people should be able to identify. Of course, people share the information about death, but they choose to share it. You can publish an announcement about the death of some of your relative in the newspaper. It's your decision. It's not official. And so why would it be made public on a website, that I don't think it would be necessary, and I think it's the kind of information which should be kept aside and kept only for statistical record, but not shared online. That's personal opinion.
More queries?
Jha and others did a study, and they got this cephology company, the C-Voter, to do a telephonic service. And they used that, as you have used your railways data, they use a C-Voter
Absolutely.
data. So if you were to use C-Voter data, yes, data, yes. I mean, if you were to use your methods with their data, have you tried changing the database and doing it?
No, in fact, their work was published just a few weeks before mine, so it was already written. And but what is likely to appear in the future, not by me, but people will do that, is that they will pull together all these different sources. And they will do what we are fond of calling triangulation, that is getting numbers and then of various sources and finally zeroing on some kind of median estimate. And we are not I mean, I haven't seen anything like that, but the JA and other study use these different sources, and not only surveys, but also death registration, and finally decided to keep one. They kept one.
And why did WHO, with its TAC, what's the Technical Advisory Committee, isn't it? Group, or TAG, Technical Advisory Group, why did they not use survey, and why
because they applied the same method of excess mortality everywhere. So it was strictly the same methodology, and they had no different methodology for particular countries. So they applied it across the world, and even, that was funny, because they applied it also in Western Europe, and some of their results were not on par with official statistics. So they found more COVID deaths maybe in France, and less COVID deaths than officially reported in Germany. I mean, there were some gaps that, in a way, show that this method of excess mortality is not PACA, is not completely robust, and that there is some margin of error due to, as I said before, deaths that were avoided due to COVID, especially in the West, or deaths that were caused by COVID but not directly by the epidemic in poorer countries where people, for example, were denied access to medical facilities.
No, when WHO came out with the estimate, Indian government was very upset. They said that you can't put us on a par with Iraq and so on. We have very robust registration and so on and blah, blah, blah. But my question isn't that. Why did they use, they are using excess mortality also, but why are they using registration data rather than survey data?
Because again, they decided to go only by deaths, registered deaths. They haven't used any other source. They wanted to have somewhat exhaustive samples, which weren't exhaustive in India because some they failed to have data for some states, so they had to do something about it. But across the board, in all countries, they use the same method, and that's WHO approach. That and now, what was strange in the reaction of the government of India is that they didn't try to encourage scientists to rework their own data set and to come up with maybe a higher total estimate of deaths. They prefer to stick to the official number rather than encourage people to maybe come up with a more reasonable numbers. I mean, that not exactly reasonable, a more reliable number that would be higher than the official estimate. So they have spent quite a lot of energy trying to reject or oppose estimates from outsiders, or including WHO, but it was the same for my own research, but not try to incorporate these findings in order to go further and maybe show that WHO had exaggerated, because a lot of people like me or colleagues have a feeling that WHO may be on the upper side of estimates. Yeah, most probably. But I think it would help if we had additional data, like for example from next census, just a question whether during the last 5 years anybody in the household has died of COVID or stuff like that, or a specific survey to reconstruct recent mortality. But we won't have that, so we just have the official data to go by with.